Hello everyone, welcome to the channel Statistica Hub. So in this lecture our topic is measuring variance and standard deviation. Variance and standard deviation. Okay. So if we are talking about the previous lecture, then we have a problem that there is a basketball team. Okay. Basketball team, and this team need a new team member. Okay. New team member. And for the recruitment of that new team member, the coach has performed some trials. And by performing the trials, he is down to three players. Okay. And our problem is that from these three players, which player should he choose? Okay. That's the problem. And for choosing that one player, we have to calculate, compare the scores of these three players. Okay. Compare the scores of three players. And for comparing the scores, we have introduced the use the concept of range, interquartile range, quartile range. Okay, but the coach doesn't just need to compare the range of player score. He needs some way of more accurately measuring where most of the values lie, to help him determine which player he can trust on the game day. Okay, now he needs to find the player whose score vary the least. Okay, that's what the coach wants. The coach wants the player whose scores vary least. Okay, now we have performed these two concepts on this basketball team choosement of the players, but the problem with these range and interquartile range is that they only tell you the difference between high and low values, right? They don't tell us that how often the players get these high and low scores. How often the player is getting these high and low scores. Low scores. Closer to the mean. Okay, closer to the mean. So the range and interquartile range gives us the difference between high and low values, but they don't tell us how often the player is getting these high and low values. And for this concept, to measure the variability, to measure the spread, okay, we need some other way of accurately measuring the variability. Okay, then variability is actually more than just spread. Okay, now we don't just want to measure the spread of each set of scores. We need some way of using this to see how reliable the player is. Okay, so we want to be able to measure the variability of players scores. Okay, players scores, we want to measure the variability of player scores. Okay, now we can do this by telling that how far away each value is from the mean. Okay, one way of measuring the variability of each player score is let's just calculate how far away each value is from the mean. Okay, if we can work out some sort of average distance from the mean of the values, we have a way of measuring variation and spread at that time. Okay, right. Now let's look at the players basketball scores. Okay, if you look at this scores, that is the first one, players score, player one's basketball score, the values here are spread out quite a long way. Okay, it is like this, they're spread out quite a long way from the mean. This is the mean. Okay, this is my mean. Now if the coach pick this player for the team, he is unlikely to predict that how the player will going to perform on the game day. Okay, because they are like quite spread. Okay, now on a bad day, however the player, this may be the case that on a bad day he have performed very like not that much good score, and on a good day he has performed like quite very well. Okay, so the problem is that we can't predict anything, that whether he will perform good on the game day or not. Okay, now let's talk about the second player. Here is the graph of the second player, at player 2 basketball. Here you can see the graph is like this. Okay, now there is a quite difference between the two graphs. Here the values are like quite spread out a long way, and here they are quite compact. The values for this second set of data are much closer than the first player's data. Okay, and they are much closer to the mean. Here this is my mean. Okay, and the variability in the data is like very less, and here the variability is like quite big. Okay, now if the coach picks this player, this second player, then he'll have a good idea of how well the player is likely to perform in each game, as these values, the scores are uh, nearer to the mean, and here the scores are like quite variable to the mean. There some are nearer to the mean and some are very far from the mean. Okay, now so the question arises is, so does that mean we just calculate the average distance from the mean? Okay, so what is it saying, that do we need to just calculate the distance from the mean, from the mean? Okay, now we are going to just calculate the distance from the mean, and let's just see that what does it give us. Okay, so calculating averaging distance, what does it give? So for calculating average distance, let's just consider three numbers. We have three numbers. Those are like let's just take 1, 2 and 9. I have these three numbers. Okay, and what is the mean of these three numbers? That is 1 plus 2 plus 9 divided by 3. That is 12 divided by 3. So we got mean as 4 for these three numbers. Okay. Now what happens if we find the average distance of values from the mean? Okay. So for that, let's just draw these numbers on the line. Here it is my first 1, it is 2, and 4 will be somewhere like here, and the 9 point will be somewhere like here. Okay, now these are the corresponding points, that is 1, 2 and 9, and this is the mean mu. Okay, this is my mean. Okay, now what do we have to calculate? We have to calculate average distance from the mean. Okay, let's do that. Average distance, average distance. Now what is the average distance? Average distance we are going to calculate is like 1 to mu, that is this distance, 1 to mu, this distance, 1 to mu. Okay, and 2 to mu, this one's distance, plus 2 to mu. Okay, and 9 to mu, right? 9 to mu. Okay, and there are three variables, so divided by 3. Okay, now what is the distance of 1 to mu? At this time my distance from 1 to mu is equals to 4 minus 1, that is equals to 3. Okay, so what we are doing is we are doing mu minus 1 plus mu minus 2 plus mu minus 9 divided by 3. Okay, now what is the distance of the 2 from the mean? That is, for this, the distance is 4 minus 2. So that is equals to 2, right? And for this 9 point, we have the distance 4 minus 9. That is equals to minus of 5. Okay, so we got mu minus 1, that is 4 minus 1, 3, plus 4 minus 2, 2, plus 5, 4 minus 9, that is minus of 5. Okay, and what is the sum of these? Minus of 5 plus of 5. So we got 5 minus 5 divided by 3, that is equals to 0. Okay, so look at this here, that these distances cancel each other out. Okay, these are the positive distances, that is in plus 3 and plus 2, and this is the negative distance, like this one. This is the negative distance, that is minus of 5. So these distances cancel each other out, and the resultant that give us is 0. So from this we got that the average distance of values, this is a very important note, that the average distance of values from the mean is always 0, right? Because the reason behind this is the positive and negative distances cancel each other out. Cancel each other out. Okay. Now, I have a question in mind that surely the distance don't cancel each other out for the all values. Is it true for the all values, or we are just lucky for this case? Okay, so the answer to this is no matter what you choose, the distances to the mean will cancel each other out. You can take any set of data, okay, take out the average of it and try to find the average distance of that data. You will get the average distance of the data from the mean, that is 0. Okay, you can check it for any set of data. Okay, now another question is, can't I use the interquartile range to see how reliable the scores is? Okay, can we use interquartile range here? Okay, why can't we use the interquartile range? Because the interquartile range only uses part of the data of measuring spread, that is 50% of the data. Okay, it uses only 50% of the data. Like if a player had a bad score, okay, if a player had a bad score, this will exclude it, because in the interquartile range, if the data is like this, then it cut out the outliers, that is the higher outlier and the higher outlier, and these are the lower outliers. Okay, so it just cut out the outliers. So if the player had performed very low score, then this will not be excluded in that interquartile range. So in order to truly determine reliability and consistency, we need to consider all the scores, consideration of all scores. Okay, and the interquartile range only uses 50% of the data. And for the consideration of the score, so for the consistency of the players, we need to consider all the scores. Okay, so we are trying to find the way so we can get the better variability and better consistency of the player. Okay, so we have taken out the concept of the average distances, but the average distances cancel each other out, and the resultant is 0. The positive and negative distances from the mean cancel each other out, right? This is the note point here. Okay, now we need some way of calculating. So what can we do now? What we can do is we can calculate variation with the variance. Okay, now we want a way to measure the average distance of the mean, of the values from the mean, in a way that, so we need that the distances won't cancel each other out. Okay, so we want the distances won't cancel each other out from mean, because if they cancel each other out, the resultant is 0. Okay, so we need a way so that the distances won't cancel each other out from mean. Okay, so the one way that from that we can stop the distances from cancelling each other out is that we need a way of making all the numbers positive. Okay, so that the negative numbers goes positive and the positive numbers are positive. Okay, so that we can add them and they give us some value at that time. Okay, the resultant is not 0 at that time. Okay, so we need to make those numbers positive, and in that way they won't cancel each other out. Maybe it will work if we square the distances first, then each number is bound to be positive, right? If we are going to square the each number, then the resultant is positive. We will gain the positive number. Let's check it whether it will work or not. Okay, so what are the numbers we have? We have the numbers like 1, 2 and 9, and we have the average of these numbers, that is 4. Okay, now what we are going to do, we are going to average the distance, like average the distance and take out the squares of this average distance. Okay, that is we are going to calculate 1 to mu square plus 1 to 2 to mu square plus 9 to mu whole square. Okay, that is divided by 3, because we have 3 variables here, 3 data points. That is we are going to do 4 minus 1's whole square plus 4 minus 2's whole square plus 4 minus 9's whole square divided by 3. So we got 3 square plus 2 square plus minus 5's whole square divided by 3. That is equals to 9 plus 4 plus 25 divided by 3. That is equals to like 24, 29. Okay, so if we calculate this, this will be 3. This is 29 plus 9. This is 38. Okay, and computing this more, we will get 3 1 times and 3 2 1 2.6, it will be 7. Okay, so this is the average distance square that we got. In this time we got 12.67. Okay, now this time we get a meaningful number. This time the distance, average distance from the mean is not 0, as the distances don't cancel each other out. Okay, now every number we add together has to be non-negative, because we are squaring the distance from the mean. Adding these numbers together, we get a non-negative result each time. That is, we get a non-negative result. We are squaring these distances and we are getting a non-negative number. Okay, now this is the method of the variance. What? This method of measuring spread, is variance. You can see it here, that what is variance? The variance is a way of measuring spread, and it's the average of the distance of values from the mean squared, because we are squaring the values. And this is the formula, this is the generalized formula. We can write it like this. Okay, so what is my variance is, if we are going to write it in one format, that is summation x minus mu's whole square divided by n. And when you are going to expand it, you will get this expansion, this type, somewhere this type of expansion. Okay, but what is the question here is, but standard deviation is a more intuitive measure. Okay, we have calculated the variance. Now what does it say? That but standard deviation is a more intuitive measure. Okay, now statisticians use variance a lot as a means of measuring spread of the data, or the spread of the data. Okay, it's useful because it uses every value. It uses every value to come up with the result. Okay, but it can be thought of as the average of the distance from the mean squared, but it is the average of distance from the mean squared. Mean squared. But why should I have to think about distances squared? Why would I think that distance is squared? I hardly call that intuitive. Isn't that there another way? Okay, so the variance has used the concept of the mean squared, but it is saying that why I have to think of the values as distances of the squared. Can't we use some another way? So what we really want is a number that gives the spread in terms of the distances of the mean, not the distances squared. Okay, so we want a number that gives the spread in terms of in terms of distances from the mean, right? Distances from mean, not distance squared. Distance squared. Okay, so what is it saying is, we want a number that gives us a spread in terms of distance from the mean, but here in the variance, because of the average distance from the mean gives us a 0, we are going to square the we do the square of the distances from the mean. Okay, but we don't need a distance squared, we need only the distance from the mean. Okay, and to get away from this concept, we need, the problem with the variance is that it can be quite difficult to think about spread in terms of distance squared. Okay, so there is a very simple concept, that is the standard deviation. Okay, and that helps us with this problem. Okay, so the standard deviation says that take the square root of the variance. It's just simple that if you are going to take the square root of variance, you will get the distance from the mean, that is not squared. Okay, so it's just simple that in the variance we have squared the distance, and when we have taken out the variance, then we are going to take the square root of the variance, and it will give us a simple value that will be the spread in terms of distance from the mean. Okay, that's why we use the standard deviation, because it will give the value, it gives us the value that is not distance squared, but it is distance from the mean. Okay, see it like here, we have got the variance that is 12.67 in the previous case. If we take out the standard deviation for this variance, it will be root of 12.67, that is equals to somewhere like 3.5, I think. Yeah, yeah, it will be 3.5 something. Okay, so the resultant here we got is 3.5. Now what does the standard deviation gives us? This is a typical values are, that is a distance. Okay, this is a typical distance from the mean. So you can depict it like this, that typical values, all the typical values that we are calculating are a distance of 3.5 away from the mean, from the mean. Okay, so it is giving us a value that is not squared, and that tell us that all the values, typically all the values are this much away from the mean. Okay, now standard deviation know how. Okay, what does it say? That we have seen the standard deviation is a way of saying how far typical values are from the mean. Okay, now the smallest the standard deviation. Okay, the smallest the standard deviation, the closer values are to the mean, closer values are to the mean. Okay, higher the standard deviation, higher the standard deviation, the values are more spread, or less closer to the mean, or you can say less closer to the mean. Okay, and what does the lowest value that deviation can take? The smallest value the standard deviation can take is 0. Okay, lowest value it can take, it can take. Okay, now how we can denote the standard deviation is sigma. This is the sign of sigma, we denote the standard deviation by this, and if we take the square of this sigma, this is my variance. Okay, taking the square of the sigma, we got the variance, and this is the sign of standard deviation. Okay, so it is saying here that hello, I am standard deviation, if you need to measure distances from the mean, give me a call. Okay, what does the standard deviation give? It gives us that it measures the distances from the mean, right? Now what does the standard deviation says? Formula for the standard deviation is sigma. So variance, we have the variance, and when we want to calculate the standard deviation, we take out the root of the variance. We take out the root of the variance, and that can also be written like sigma square is equals to variance. Okay. So these are variances and standard deviation, that how we can calculate standard deviation and variances. Now let's just do an example of this so you can get a more clear understanding of this concept. Okay. Now it is saying that calculate mean and standard deviation for the following sets of data. Okay. Okay. So let's just take out the mean for this same set of data. Okay. When we have this, for the mean we have to add all these values, and what is the addition of all these values? 1 2 3. Okay, it is like 3 6 4 5 6 7, so it will be like 28, I think. Okay, 28. And how many values these are? The 7 values, so 28 divided by 7 is the mean. So we got, what is 28 divided by 7? 4. Okay, so we got mean for the first value, that is 4. Okay, now what is the variance for this? For the variance, we know the formula, that is sigma x minus mu whole square divided by n. Okay, this is the formula for the variance. Now let's apply it here. We'll get like x minus mu, that is 1 minus, what is my mu? Mu is my 4. This is the symbol for the mu. Okay, 1 minus 4 whole square plus 2 minus 4 whole square plus 3 minus 4 whole square plus 4 minus 4 whole square plus 5 minus 4 whole square plus 6 minus 4 whole square plus 7 minus 4 whole square divided by 7. Okay, we are going to calculate it. This will give us 3 square. It will give us, I'm sorry. This will give us 2 square, this will give us a 1 square, this is zeros square, and this is sorry, this is 1 square, 2 square plus 3 square. Okay. Oh, sorry, it is minus here. Minus 1s, minus 2s, and minus 1 square. Okay, so we got these values by calculating, and this is divided by 7. Okay, now let's just calculate it. That is 3 3 are 9, 9 plus 4 plus 1 plus 1 plus 4 plus 9 divided by 7. Okay, what will be the sum of all these? That is 9 to 18, 8, 2, 18, 8, 2. Okay, that is 28 divided by 7. So we got variance that is equals to 4. Okay, now if you want to take out the standard deviation of this, that is root of square root of variance. So we got standard deviation as 2. Okay, similarly we will perform for the second part. Okay, that is this one. If you want to calculate the mean for this part, what will be the mean at this time? So it has the 6 values. So my n is equals to 6 here, and the sum of all these values will be like 21. Okay, 21, and it will be, if we divide it, it will be 6 okay, 6 18, 3.5. So we got mean, that is mu is equals to 3.5. Similarly, calculate the variance for the this problem, and like we have done for this problem. Okay, for this we will do 1 minus 3.5 square plus 1 2 minus 3.5 square plus 3 minus 3.5 square plus 4 minus 3.5 square plus 5 minus 3.5 square plus 6 minus 3.5 square divided by 6. Okay, now let's just simply compute it. We will get something like uh, minus 2.5 square plus minus 1.5 square plus 0.5 square plus 0.5 square. Okay, so it is minus here, sorry. 1.5 square plus 2.5 square divided by 6. Okay, now what is the square of 2.5? That is 6.25 plus 2.25 plus 0.25 plus 0.25 plus 2.25 plus 6.25 divided by 6. So we got something like the addition of all this, this would be somewhere like 17.5 divided by 6. Okay, so we got, if we divide it, we got like 2.6 okay, 2.9 something. Okay, let's 2.92 for the two decimal places. Okay, so 2.92, and the standard deviation is root of 2.92. Just calculate the root of this variance, and we will get the value, that is that corresponding value is my standard deviation. Okay, so that's how we can calculate the standard deviation and variance for any particular set of value. Okay, now it is saying that these calculations were tricky. Isn't there an easier way? Okay, isn't there an easier way? Like in this calculation, it is quite tricky that we have to take out the average first, and then we have to subtract the average distance, squared average distance, and then add those average to average square distance, and then take out the, then it will give us the value of the variance, and then we have to take out the square root of these values of the variance. Okay, so we will, in the next lecture, we will see some easier way to calculate the variance. Okay, so that's all for now of all this lecture. Thank you.